The purpose of this video is to do a more in-depth investigation into how to rerun your cluster analysis and your SOM solution to get at a better or more refined understanding of your data set. Up to this point, we've talked about how to actually run the artificial neural net, that is the SOM. There's a video on that. Then making sense of the visual map, which is all of this information that you get, which is also called the SOM grid or variously other names. And then comparing the artificial neural net solution to your cluster solution. That is looking at the cluster solution from K-means. If the viewer recalls from previous videos, this being the K-means cluster solution 3, cluster 3, case 14. Right? If we go back to our cluster, here are our cluster, here are the centroid scores. That is the average score for the cases in this cluster. Cases 11, 10, 21, 7, 16, 9, 4 are all members of cluster 1, and that's their centroid score. And we have a basic sense of what that cluster solution is compared to the cluster solution arrived at by the SOM. Again, each quadrant representing a cluster solution. So for example, putting all of the cluster 4 K-means solutions together over here and the cases that belong to it. So we've explored that, but what do you do when you want to start refining that or rerunning that or exploring it? Again, in the previous video, which we did on comparing artificial neural net to cluster analysis, we did do a bit of running, but in this one we want to spend a little bit more time rethinking that and examining that. So if the viewer recalls from the previous video, we ended up pushing this up from 4 to 6 clusters. And the reason was that when we looked at the data set, we saw that there was some distinguishing differences between those cases that were struggling or the communities that had the worst deprivation. If you see over here again, to remind, these are the profiles for this particular quadrant or this SOM cluster across the 7 variables, 1, 2, 3, 4, 5, 6, 7. So when we look at our results, this is below the mean and this would be above the mean. These are the scores on that, and we can get it even further view of this by going to the prototype bar plots, which really highlights the distinctions a lot clearer. But looking at that in terms of the observations, one of the things that we saw was that this group down in here, they're doing very good all around here, but this cluster here over here of deprived communities struggling the most, we noticed that between them or amongst them that these last 2 factors seem to be playing a distinguishing role. And those last 2 factors are violence and theft. So one of the things that we did was we pushed the cluster solution up. We also noted that the F score for this, the unstandardized score, was 69. However, when we run a 6 cluster solution, we get a much stronger F. We also get a further breakdown of the profile. A bit of concern is that this case 16 is going in the opposite direction from the others, which is problematic and should be thought through. Generally speaking, you want your cases to be going to the right to suggest that they are fitting that plot quite well. So maybe we try 7, see what happens. We lose a bit in the overall fit, but we have things slightly more in line. We can take a look at that. Then we could try a 5 cluster solution. That's getting also a nice fit and also has clusters put together, and with such a small database might be a more viable solution. So we have our 5 cluster solution. We'll just check it a couple times and explore the solutions. That's obviously a very low one. So this one seems a reasonably good fit. We then can move on to the training of the SOM and see what kind of solution we get. This seems to be a pretty good fit. And then we can move on to take a look now at our distribution of clusters. We see that in the 5-cluster solution, all the 5s are over here very nicely. We have 1 5 over here, which we could take a look at case 5y. But they're all over here. The 2s and 4s are over here. Our 3s are up here. And the 1s seem to be distributed a bit with a 5 over here. So one of the questions then becomes, well, what's going on in the data? We do see that these are the communities that are thriving the most, quadrant 21 being the strongest and spread out. What we do see, though, is that this more refined table suggests that these clusters might be a little tighter, but we can go into here and try a 6-cluster solution and see if that gives us an even cleaner distinction. And it does. It shows us that we have now over here, up here, really the communities that are the most healthy going down across. We have the communities over here that are the most struggling in terms of deprivation. And then the crime communities are situated over here, where crime plays a key role, even though they're otherwise reasonably okay in terms of deprivation. And so if we look at the names of the communities there, we do see some rather interesting highlights here that all three cases put in cluster 5 down here are significant in terms of crime and theft. And if we look over here in terms of crime and theft, it is indeed, it's got the highest level here in terms of violence, really pulling, and one of the highest scores in terms of theft, with the next being 3. So if we take a look at where cluster 3 is on the grid, we see 3 is down in here and 5 over here. But what we see then, going back to the bar plots, is that 3 is having issues of crime and violence, as are cluster 5. But really the key here is this is a deprived community where crime and violence are part of an overall picture, where these particular communities, it really is about crime and theft. So this type of distinction becomes very interesting, and it's one of the strengths of the SOM package is that you can run and rerun analyses and explore them. Some people in their negative critiques of a data mining and computational modeling approach call this way of doing data analysis data dredging. But it's an exploratory process by which you're looking at a complex combination of factors and variables. Obviously, therefore, one does need to be careful in overfitting the data, for example, which means pushing these cluster analyses and SOM solutions so far that they're so local to just this data set that they don't give you information on generalization purposes. So one always needs to be careful with the data, and that's why in the opening we have K-means as the first step and then the SOM as the second step, because K-means at least requires you to have some idea of what you're looking for cluster solution wise, given present literature, theory, hunch, or expertise. Okay, and with that, that gives you a good sense of how to approach things.